Before we start with this, I'm going to get Jada to come up and take a couple of pictures. I've been told that I need 2 new social media photos, so we're just going to do that now. I figured with this background it'd be good. We need a serious one for LinkedIn.
Right. Great. Work it.
Okay, and then we need a hip, cool thing for the LinkedIn kids.
Oh, nice.
Yeah, cool. We got it. Thank you. I'll give those to Mike later. So, yes, okay. So, Morton said there wasn't going to be another discussion about array notation. I had preliminarily entitled this Array Notation Again, really. Decided that wasn't necessarily appropriate. Given that, in 2015 was when we first started speaking about APL array notation. Phil Last introduced it, and here's a snippet of array notation from back then. And then in 2017, Adam brought it up again, and here's another slightly different bit of array notation. And I thought, well, maybe I should do a retrospective, and we could talk about it and how it's evolved. But it turned out in 2018, Adam did a retrospective about array notation. So, there was no point in me doing that. So I landed on array notation, a journey of discovery. And this is, Jada summarized it quite well. I've often been quite vocal, but not necessarily very communicative in my reluctance to adopt array notation. And I felt it was time to grow up a bit, time to not be the petulant, slightly grumpy child. Yes, it's me. And also, not be that happy-go-lucky kid that was just happy to accept everything that he was told and just say, that'll be fine. I needed to be a grown-up about this. And try to figure out what it is I didn't like, try to understand what the impetus was, and to try to embrace the thing and see what was going on. And that's what brings us to 2024, me, today, now. I'm not going to talk about what array notation is. We've been talking about it for 8 years, and you can go here and you can read about that. And we're going to see it, and I'll explain in passing what things are doing, but we're not going to be discussing what array notation is. What I will talk about, though, is what I see as being the very 3 distinct usage cases of array notation. The first one, which is pretty much the only one up until now that anyone's been able to use, is to use array notation as a way of serializing your arrays to files. Okay, so you can read them in again afterwards. That's the first thing. But we're also going to talk about, what array notation might mean to how you write your code, and how the introduction of array notation might affect how you look at your variables and manipulate those and so on. And now I said to someone at breakfast, I don't believe anything that's written on a PowerPoint slide. I need to see demos. So let's move over to a demo. As I often do, the PowerPoint is running on my Mac, but I've got a virtual machine which is running a Windows desktop. So I'm going to start my array notation version, and hopefully the fonts are okay for everyone at the back. I did check this, but if you're struggling, give me a shout and I may be able to make that larger. And I'm just going to sit here and press F12, because typing is difficult. It's even more difficult when you're standing up, and when you're standing up and talking, it's practically impossible. So I'm going to load a workspace that's got some stuff in it. And I'm going to switch boxing on, because that's always useful. So here is some text in Notepad in a file, and we will all recognize this as being a vector in array notation. And in Dyalog APL, I can use we've got a couple of I-beams that can be used to deserialize that form into an array. So we've deserialized that into a 2-element array, each with 2 elements. I've got a function here now which will allow me to show you a couple of files. Here, for example, is a matrix containing the same data. Okay, we can fix that, we get an array out, and it's a matrix. This is the stuff that we've been showing before, but it sets the foundation for other things. We can have a namespace in a file, okay, and then we get a namespace back and we can get the information out. No surprises at all. And we've also got quantity.dialog.array.serialize, which goes in the other direction. Okay, there's nothing in the interpreter to serialize an array, we're still using APL code that's been written, I think, by Adam to do that. It's very convenient that it's written in APL. We can tailor it, we can fine-tune it, we can do all those sorts of things with it. Not only can we do that, if it doesn't do what you want, you can change it as well. So we can round trip all of these things. Oh, right, okay, right, so I went too far. So here is another file. Okay, here is a file that looks like it contains array notation. Okay, it's a 2-element nested array. The first element is 1 through 10. Second row contains IO to 10. Okay, now this serialized form of array notation that you might put on a file does not allow the evaluation or the execution of arbitrary APL primitives. So if we try to fix that, we get a message that says IOTA is not permitted in safe execute. Now all of these words might change, these I-beams might change completely, but the point here is that there are a large number of things that you cannot do in serialized row notation. It's intended to be a literal representation of your array. Okay. So here's another thing we can do. We can't use multiply. Okay, there we've got a multiple. We're erroneously trying to add VAT to our flight prices. We can't do that. Multiplication isn't allowed in literal array notation. We are allowed to do zero compress because array notation on its own doesn't make it easy for us to create empty arrays. Okay, so we can use zero compress and we get an empty array out. What we can't do is replicate. We can't replicate 5 rows. Okay, the intention is that it's a literal notation, and those primitives that you need to use to get around the little edges that array notation doesn't do on its own, you're allowed those, but you're not allowed anything else. So, to summarize that first little part, serialization allows you to save your stuff to files. We've been doing that for years. Link does that every day. Usually that's with no APL primitives, but some are allowed if you really need them. And we use I-beams for deserialization, and there's still a APL code going on for serialization. So that's old school array notation. That's serialization, that's putting things in files, that's saving your data, that's reading your data. It's great, but it's potentially 10% of the usage cases of array notation. Let's come to array notation now in code and how our code might change. I'm going to look at a function called vectors, and I'm just going to fill this function in a line at a time. So here we've got an APL expression that uses stranding to create a 2-element nested array. But now with array notation, I can type the same thing with fewer parens. We've got I haven't got a light, unfortunately, so Andy said use finger mark 1. We've got an open paren, we've got a diamond. It's the diamond here that tells us this is array notation and not a syntax error on the diamond. Okay? Or we can spread our array notation around over multiple lines, and you'll notice when I put line 9 in, then the syntax color all fixes up, and we get some nice formatting of our input. So now for the first time, we're seeing array notation inside executable code. And that's, the serialization might be 10%, maybe this is another 10% of the usage cases. So this function is now just going to display these 3 arrays so that we can make sure that they're all the same. And hark, I hear you all say, this is a little bit confusing. We're sort of overloading the parentheses here to do 2 different things, and I can't keep track of that. Okay, so let's go to our syntax coloring. Let's pick the new array notation element there. And for the purposes of demonstrations, I'm going to make this as loud and as noisy as I possibly can. Is that green difficult to see? I can probably change that color to something it may be a little bit too pale. Let's change it to a gaudy pink. Yeah? Okay, so we can now easily identify where our array notation is and where our regular parentheses are. That's an improvement. So what we're going to do now is we're just going to run the function. So there's a function, we're going to run it, and we can see now that the output we're boxing on, we have the same array 3 times. We use 3 different ways of specifying it, but we've got the same array 3 times. We can do the same thing with matrices. Okay, I've got a number of matrices here. Again, we've got a single line APL definition. We've got a single line, we're using mix, we're using reshape, we've got a multi-line array notation, and then we've got another multi-line array notation here. But you'll notice here, that we are allowed to use multiplication because we're writing code here. We're not serializing an array, we're not persisting anything, we're not in that literal mode. So we can use multiply, or we can use any of our own user-defined functions here. We can put any stuff here that we like. So if we run this guy, there's the function, and there we can see that we applied uppercase and we added VAT incorrectly in the UK to the prices of our flights. So we can embed any code within our array expressions inside code. And this is nice because this then means, that the formatting of these is such that I can just make that as big as I like and run the thing again. Why didn't that work? Oh, because I reassigned M3 down here. Never do anything different. Okay, so now, there's other ways of typing that, but with array notation, it's nice and clear. We can just replicate that up. We can do namespaces. Let's trace through this one. Not that, let's trace through this one. So here we're using quad and S quote to create a namespace. We can dig out the destination of the price, and we can see down here that flights to Glasgow are £126.98. Here we're doing it with a multi-line namespace notation, but it's the same thing. Here we're doing it in line. We're not assigning the result of anything here, well, except a quad output. We've got a literal namespace, close paren on the literal namespace, dot, then a normal paren to get the destination and the price out. That does the same thing. Here's an interesting one. We've got a literal namespace being used as an argument to a function that takes a namespace as its argument, and it just digs out the same information. So again, 4 or 5 different ways of defining, creating namespaces and using them. Nice and easy. It's another 10% of your usage case of what's array notation good for. Here we got something. This is just a function that returns a nested array. It is a vector. R gets open paren. That tells us it's a vector. The first row is a single line of 2 flights as a vector. The next element is a matrix of flights. And then the subsequent array is a 2-element array of it's just an array, but it's in array notation. It's easy to read. We can look at it. We can index into it. We can do all the normal stuff. Okay, so that's all very cool. Let's just go through this again. Morten mentioned token-by-token tracing. Let me just reiterate what that is. We're in the regular tracing. Now, normally in APL, we'd go through this a line at a time. But now with token-by-token tracing or primitive tracing, I'm still not sure what to call it, I've got a keystroke now that lets me trace through an expression an element at a time. So we've got here, we can see that we're about to apply the mean train to iota 10. And as I step into this, we can see that it's first going to do the tally, then it's going to do the plus reduction, then it's going to do the divide, and the left-hand side of the divide is the plus result of the plus reduction, and the right-hand side, the 10 in the top there, is the result of the tally. But then this also works with expressions with array notation. We're going to highlight the times there because we're applying times to an array on the left and the array on the right. And I've got the option now in our configuration box to say, always use array notation. You know what? I've gone out of order and it's going to annoy me. But no, let's do this anyway. Let's do this anyway. It's okay. I'm this far. So if we do that now, the next time we go into a primitive, hold on. Next time we go. So here's an interesting thing. This is a VM running on a Mac box, and I've noticed that when Windows wants to display a semi-transparent dialog box, sometimes I get a little bit of a hang and the screen flickers and then it goes away again. But so now if I do this again, hopefully we'll see now that our left and right are displaying an array notation. I mean, in this example, it's exactly the same as in the code, but if it was in any other form in the code, we'd have it nicely expanded in the token-by-token tracing. So again, we're getting that visualization using the array notation in a context where it's useful to us. And as we go through this function, we'll see that there are various things going on. And here we've got this example here where we can token-by-token trace into the first multiplication on the first row of the matrix. Then we can Now, this is very annoying because Mort said at breakfast, it's not a proper presentation unless you get a sys error in it. It's especially annoying in that I did experience this and I did fix it. It's thirdly annoying because now I'm not entirely sure what else is going to be susceptible to breaking. Now, why? But why has that gone wrong? Okay, we'll come back to that. We'll do this all again on another day. Right, okay, so let's look at some things. Here is a function. What it does is it creates 3 functions. One creates a 10-row matrix by creating a nested array and mixing it. Okay. The other one, the next one, creates a matrix by just creating a 0-row matrix and then adding rows one at a time. Third function just uses array notation to create a 10-row matrix. And this per function is now just going to run all 3 of those. It's going to give us some numbers, and we're going to see which one's better. Guess. Just have a bit of a guess. Which one do you think is going to be faster? Okay, so the array notation is half as quick as the others. Not necessarily a surprise, because you look at those. There's clearly moving parts going on in all of those examples. If we ran this with bigger numbers, we get a better performance improvement. If we try to run this with a big number, we actually get failures. The ones here are coming back from QuadFX failing because we can't have a function with 5,000 lines in, and some of those notation expressions were big enough that we couldn't put them all in a function. Now, this is going to run this performance, but it's going to give me misleading results because the asterisk here tells me they return a different results. And that's because when I did 1, the first expression returned a scalar, not a vector, which is why it would return a different result to that, which was why my compex wasn't good. So anyway, so what we've got here is we're creating a 2-element nested array, the first way with stranding, second way with array notation, and we're going to compare the performance of those. And who's going to guess? Okay, so the array notation is a little bit, 20% slower. That's not great, but that was for a 2-element vector. Let's pick a number. What's a number bigger than 2? 5? 5 is bigger than 2. So now we've got 5 elements in the stranding. We've got 5 elements in our matrix, in our array notation. 5 was a good choice. It's now 15% faster. Let's up the ante a little bit. In fact, I guessed 5. This is my F12, so someone's going to say 12. Let's do it for 1,000. So this, goes to the hospital ward at the end of the thing. There's 1,000 elements there. There's 1,000 rows here. So, you look at that, you think there's no moving parts even in the stranding. There's parens in there, there's stuff that the interpreter's got to figure out. The array notation specification, you look at it, pretty static, no moving parts. No moving parts, great. The interpreter's got nothing to do. It can run that expression that does nothing even quicker than the other thing that did nothing. What's next? Oh, back to the PowerPoint. Hurrah! So array notation and code. Oh, is a demo. Okay, so we've seen now there's no restrictions on the functions that you're allowed to use there. Okay, we use the upper, we use the multiplication. Well, we could have used anything in there. It's easy to edit that notation. You don't have to worry about copying parens around and adding in brackets and all sorts. It's just, that's easy to use. And we can disambiguate the uses of parens and square brackets, so there's no concerns there. We can do it with the syntax coloring for readability, and the syntax is such that that's all fine. But there are some limits. It's got the same limits as we've got with code, and Morten mentioned some of these. And that's why we want to look at those limits now, because if we encourage the use of array notation, maybe you're more likely to get to some of those limits than you would have done before. And I'll be talking about that on Wednesday. So now let's talk about array notations and variables, because this is when the other 60% of usage cases that I've not talked about yet kick in. So if I try to edit this, it's not particularly interesting. It says it's a read-only nested array. It looks nice, but we can't do anything with it. However, one of the things we've done is we've retired David Liebtag's editor. One of the reasons why we've done that is because this button up here now says edit with array notation. So if we edit this with array notation, what we now get here is we get our square brackets and our rows. But we can now edit this. So I had got the year of the matrix resurrections incorrect. Okay, so I can fix that. I can come out of here And now my matrix has got the new data in it. My nested arrays now have become editable. That's cool. But more than that, I'm going to, right, so there's a number of ways getting into the editor to do that. We can prefix our, right, so if I do paren the matrix, then it takes me to that directly, okay? Another thing that I personally like doing is I can just use shift-add over the name, which gets me the read-only version. I can shift-enter again, and that takes me to a version that I can now edit, okay? So I can do things inside here. I can say, let's add, I missed this one, let's add the animatrix. Okay, and we can fix that and we can come in again. We can say that, you know what, I've not got the case of that right. Let's apply a title case function to that. So what I'm going to do now is I've got a keystroke which is going to evaluate the content of the edit window and replace the content with the result of the expression. And you can see, well, it's an editor. We can do undo. I'm going to undo. Okay, so here what I did is I typed title, and I have the animatrix in all lowercase, and the title function takes character vectors, or at least a matrix that contains character vectors, and converts all the strings into title case. Let me do this in two steps. Let me, first of all, make everything lowercase. So I'm going to evaluate that. Everything's become lowercase. Okay, I'm now going to title case that. Everything becomes title case again. So I can apply these arbitrary expressions in my editor to affect the array that I've got without having to go back to the session and figure out what APL expression I need to do. I can just do it all in the editor. And I can fix this. And now I've got the animatrix. I've got all my casing nice within, all by doing all of that work inside the editor. Let's try doing inline namespace definitions. Okay, so here what we've got is we are now we're starting a vector, open paren, we're starting a vector. The first row of our vector is a namespace, the first element of our vector is a namespace which contains a title field, which is a matrix which was released in 1999. Then we've got the next matrix movies, and we can spread these definitions out over multiple lines if we want to. Okay, and we've got vector of namespaces. We can edit that. Okay, here's your first moment. I'm going to hit Shift-Enter on that. Now we get the namespace notation of all of these things. I'd made the same error on the year for the matrix resurrections. I had 31. It's 21. We'll fix that. We'll look at our array again, and it's all gone from 2031 to 2021. Okay, because we've now got this array notation which allows us to edit our nested arrays. Not every nested array, there are things that can't be represented in array notation, but for those that can, we can just manipulate them with the editor, and life just gets a little bit easier again. Here's another thing. Here is a nested array of text. Okay, well this looks like it's comma-separated data, doesn't it? Let's make this editable. Let's just do quad CSV on the enclose of the data. I'm going to hit my evaluate function. Here we now get the array notation for the comma-separated array. We can now just treat it as a matrix. Just by looking at the data, thinking, well, that looks like it's this. Let's apply the manipulation that we need to do in the editor. It changes the arrays if we typed it by hand, but hey, we don't want to type things by hand. And all of a sudden, now we've got our matrix out again. If we want to create a new variable with array notation, we could just do array diamond var, and then we can just do 1, 2, 3, all right, blah, 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 blah. We can go straight in with array notation if that's how we want to define our arrays. I'm running low on time, so I won't go into that. What I'll do is I'll jump to the cool stuff. The box is off there. We don't care about that at the moment. Don't care about that. Okay, back to the PowerPoint. Do we want to go back to the PowerPoint? Okay, right, yeah. Okay, just a summary. We've retired David Lee Test Editor because you can do so much cool stuff now in the editor. It's gloriously easy to edit most variables. And we can create multi-line arrays and namespaces in the session interactively as we've been doing with functions for the past few years. And finally then, and I'm going to show you some stuff now that I suspect won't be in 20. All of that stuff probably going to be in 20. I mean, there may be changes and maybe tweaks, but broadly speaking, that's the functionality you can expect from array notation in 20. What I'm going to show you now is just some cool stuff that sort of falls out of this, but it's got so many edge conditions that we might not just get it into 20. Now, I've done that. Something cool. Right, so here's what I'm going to do here. I'm going to spin up Excel. Hopefully I'm going to spin up Excel. Who knows? Right, yeah, great. Here's Excel. Here's an expenses claim form. We're familiar with this data now. And Excel has got a active sheet property, which has got a used range property. So what I've got here in used is, I'm going to enable some features. What I've got here in used is an element, the value of which, or the value to of which, is the nested array of that Excel spreadsheet. I can convert this into array notation. I can add £1,000 to my expenses. I'm not going to be able to claim that, but I know a man who can. I can't spell his name, but I know him. Now I'm going to come out of the editor. And bang, it's updated the spreadsheet as I've come out of the editor. Look, it's Morton's claim now, and he's £2,000 up. So now we can edit nested arrays. Where can we get our nested arrays from? And it turns out, well, Excel is another place where we can get our nested arrays. So I'm not going to do that a second time. We're going to close that. We're going to quit that. And then, following on from that, let's look at something else which might be useful. I'm on my last minute, and then there's going to be a couple of minutes for questions. Let's say we want to edit the HTML property of a HTML renderer. We've not been able to do this before because all properties and objects have been ineditable things. You had to do them by assignment. But if I change the, so I'm just going to do hello world, and what we'll do is we'll make that bold because we can. We'll make that bold. Well, no, we won't make that bold. I'm going to hit escape now, and when we come out of there, the HTML goes populated straight into there as a result of the editor. Let's move this dial up another notch. Okay, let's do another magic thing. Let's edit my HTML again. Now you'll see that the interpreter has basically said, oh, this begins with a less than sign, it's probably XML, so I'll provide some XML syntax coloring on this. Okay, but that extra bit of magic that I've just done means that this changes now as I type. Okay, which means that, you know, I can start doing things like this to put things on new line. Okay, I can go to a browser which has got some HTML in it. I can copy that. Oh, no, hopefully I copied that and didn't screw anything up. I can paste that into there. We get the table there. I can do things with this. For example, I can say, well, I don't want my border. Wish I hadn't done that. And I certainly don't want to do that. Let's do that. I don't want my border to be black. I want my border to be red. I don't want my border to be 1 pixel. I want my border to be 3 pixels. I can say, now, yeah, I've done that. Don't want to do that. I can say, let's change the, it's in the wrong place, isn't it? Where does that go? Someone tell me where that goes. No, I think it has to be in the table, doesn't it? I'm so out of time. If you've got, right, there we go, we can change the font size. Okay, and then as we change the font size, we can do stuff. We can change the font size again. We can just go through. We can add new rows. I mean, it's just, you know, wouldn't it be nice if I was learning HTML, I was teaching HTML, and we could update stuff in the editor dynamically. And we can, and it works, and I've got more examples of that, but I think I'm out of time, and I think I need to take questions. Oh, no, but to summarize. Journey discovery? Yes. So this guy, he'll probably go, I don't like it very much. This guy will tell you anything you like. He just wants to keep you happy. He wants to be happy himself. And this guy, okay, he's been thinking about this. He's been working on this. He's done some implementation. And he sort of comes to a conclusion, which is, you know what, it's okay. So I hope you come away from this having learnt at least a couple of things. Okay. The important things that you take away from this are that the price of a flight from Glasgow is £126. But it's cheaper to go back. It's the wind direction. I don't know. Thank you for your time. Thank you for your patience. Things haven't worked, but I hope you get the gist. There's a birds of a feather on Tuesday. We can go through this all again. We can play with it. I'll mend things so that it all works. The interpreter limit stuff I'll talk about on Wednesday. That's interesting. It's quite technical, but we're technical people. It should be fine. I'll take questions. I can't answer the question, why didn't it work? Don't ask me that one. I've got no idea. I hope it's been useful. Please, questions.